Welcome to a lesson with Dr. Powell. Let's take a look at how we can practice with exponents a little bit. All right. First of all, this is a root symbol, third root. It means that we can raise this whole thing to the 1/3 power. Next, we think about what this thing does. All right. It's an exponent and it can distribute over multiplication and division. Division is the same thing as multiplication um, by a fraction. So and exponents distribute that way too. Okay, because they're repeated fractions or repeated multiplication. It's just fine, or multiplication of fractions. So we get something like this. So this 1/3 will be distribute. And as it distributes, remember what it does. It multiplies to the exponents. There's a 5 to the 1 and 2 to the 1. Should make sense. 1 times a third, right? So this will become 2 to the 2/3 times 5 to the 1/3 all over 5 so 3 times 1/3 is to the 1. And then we have times 2 to the 1/3. All right. Now it'd be nice if we could like cancel things out on the top and the bottom that like we could divide top and bottom by the same thing or something to make this a little bit simpler because we see a 5 up here and a 5 down here. Now remember what exponents do across multiplication or division when they have the same base. They turn everything into addition. They turn multiplication or division into addition or subtraction. So let's identify the parts that are the same and kind of put them together. So this is like 2 to the 2/3 and 2 to the 1/3. That's together. Then on the other side, we have 5 to the 1/3 and 5 to the 1. So right here in this division with the same base, these exponents turn into subtraction because it's like counting how many twos you have or factors that you're adding or dividing or whatever. And here you have 1/3 that you're subtracting because it's divided. And here you have 2/3 that you're adding. So it's kind of like you have 2 to the 2/3 minus a third. So 2/3 minus a third in that exponent. Over here you have 5, and this is time still right there. And then you have this exponent, a third, minus this one, minus 1. So 2/3 minus a third is just a third. So that's 2 to the 1/3. And here this is 5 to the 1/3 minus 1, which is 5 to the negative 2/3, which then you could rewrite as 2 to the 1/3 divided by 5 to the 2/3. Now, why could we write that as 5 to the 2/3 down below? Because remember what this negative exponent means. It means that we're dividing by whatever we have here. So we can put it into a denominator just like that. So we get 2 to the 1/3 divided by 5 to the 2/3. Okay, and even if we wanted to, you notice how there's a common 1/3 factor here we could put out. This is like 1 times a third and 2 times a third. So you could pull that out and undistribute it to the whole to make it 2 over 5 squared to the 1/3, which, using our notation from before, we could write as 2 over 5 squared, but I'll write it as 25, and then we have a cube root. So all we did was just rewrite this in this form. Wait a minute, there's probably an easier way to get here. In fact, there is. Why in the world did I go this route? Just to show you some properties of what we can do with exponents and subtraction and combining. But how could we have gone here more simply? Maybe we could have just started working within the fraction right here. Maybe we could have seen, okay, 5 and 5 cubed. I have 1 factor of 5, 3 factors of 5 at the bottom. I can cancel 1 factor there, and one of the factors here to make that a 2. Here I have a 1 factor of 2. I could get rid of that, and I have 2 factors, so I can get one of, right, because I can get rid of that 2, and then one of those factors to make it a 1. So it's 2 over 25. Oh my goodness. And I had to go all that way around. Well, the only reason why we did that was just, like I said, to kind of see how these properties interact and how they can work together. And maybe they would be necessary if we had another scenario. Like, what if we had like a different root symbol, like on the top versus the bottom, like in something like this? Maybe we should explore that one now and see how that would go. Okay, so let's take a look at this one. Here, let's see, 4 cubed times 3 to the times 3 to the fifth, right? Square root. Maybe we should just distribute all this in. So here, thinking of the square root as a 1/2 power. Okay, let's just get rid of all that, and we're done with this example. Just kind of clear the way. All right, so we can think of that as being 4 cubed times 3 to the fifth raised to 1/2 power, all divided by, and then here, this is 4 times 3 to the sixth, and to this fourth root, think of that as raised to the 1/4 power. Now these exponents can distribute in, and so as this comes in, it multiplies to the exponents, so it becomes 4 to the, so 3 times a half is just 3 halves, 4 to the 3 halves, 1/2 times the 5 is just 5 halves, times 3 to the 5 halves, all over, and you multiply the fourth in. So 4 to the 1/4 times 3, and then this is 6 times a fourth. So it should be 6/4, which is, you can reduce 6/4 to 3 halves. Okay, great. All right, so now what do? We see we have the fours together and threes together already. We can kind of think about this as being like two separate fractions if we want. I'll multiply together like this. And since it's the same base right here, we can just subtract this 5 halves and 3 halves. Subtract 5 halves from 3 halves, what do we get? We get just 2 halves, which is 1. So we get 3 to the 1. So this part right here is just simply 3 to the 1, because you're just subtracting the exponents here. Now this part right here, we think, okay, 3 halves minus a fourth. Okay, so we need to subtract. So we think 3 halves minus 1/4. And how are we going to do that? Well, we need to have a common denominator. So now we need to rewrite this fraction. The only way to rewrite a fraction is to multiply top and bottom by the same thing, or divide top and bottom by the same thing. So multiply top and bottom by 2, and that'll give us the same denominator. So that would give us 6/4 minus 1/4. And of course, you could even, if you want, you could even think about the following. You could think of this as, I mean, this is pretty simple. You might see it's 5/4, but I'm just going to talk about it for a second nonetheless. I'm going to think about this as being 6 times a fourth, because it'll teach principles, minus 1 times a fourth. You see how this 1/4 is common? You can think of factoring out the 1/4. That means like undistributing, like going backwards on the distributing process. 1/4, 6 minus 1. So of course it's 1/4 of 5. Same thing as 5/4. But what does it illustrate? It illustrates that adding fractions, getting a common denominator, is the same thing as getting a common factor that you can undistribute. So really, adding fractions is just common denominator means common factor that you can undistribute, and then you just add what's left over. Oftentimes people forget this idea or don't even see this idea, and because of it, things go awry, or it's just, you're messed up, like how to add fractions. It doesn't make sense to them. But the more you see kind of how this works, the more that you don't forget it. So in this sense, so what do we get? Let's go back to our thing. That was just a tangent that I was off on, just kind of talking about this. But here, what we end up getting was, remember, this was we were just working with the exponents. So 3 halves minus the fourth, right? So 3 halves minus the fourth, and it becomes 5/4. So this is just 4 to the 5/4. Okay, so this can be rewritten in this way. Now, if we don't like fractional exponents, then what can we do? Perhaps we could, so let's first write this as 4 to the 5 fourths times 3. We could look at this and maybe think of it as 4 to the 5 times a fourth times, and then this is the number 3 down here, but this is up, this is multiplication is up in an exponent. Then we can think about this as simply being 4 to the 5th, and then putting parentheses here with the 1/4, because remember what what exponents do with parentheses, they multiply in. So naturally we can do that, and sometimes we can just use parentheses like this to signify multiplication. Why would this be useful? Because now we can write this as a fourth root. So we could simply say this guy right here is simply the fourth root of 4 to the 5 multiplied by 3. And if you really like, if you don't want to put a multiplication by 3 on that side, because this is a root symbol, it's just preference really, but it doesn't really mean it. But you could write it on the other side as long as you parenthesis it or do something to signify that 3 is not underneath the root symbol. You could say 3 times the fourth root of 4 to the 5. And that would be a simpler way of rewriting this expression. Then again, when we simplify expressions, we're just rewriting the expression in simpler form. What are the key things to look for in an expression when we want to write an expression in simpler form? Well, there's lots of things, but in the examples that we were looking at with multiplying by things, we like there to be, so we were looking at fractions where we had lots of multiplications, divisions, square roots, or whatever. The one thing that we like to see is we want to have one instance of each factor. So what a factor is something that's multiplied to get to something else. So, I mean, notice we had lots of 2's. We just want to see 1, 2 in the result. Aside from exponents, don't worry about a 2 being the exponents, but just a 2, or maybe just 1, 5 or 1 whatever. The exponents, though, however, it doesn't relate to that, just kind of what's down below. Then also, maybe perhaps we want to, in the end, use, this is a preference. Sometimes we don't want this. This is just sometimes, and what some people like looking for, root notation. It just depends on what you're doing. Sometimes the fraction notation is actually better. So this is just, this is a matter of preference. But at least if we can get one instance of each factor, that would be good. Root notation. The other thing is no negative exponents. So change your expression so the exponents, you don't have any negative exponents. So that is, if you have like an exponent like 2 to the negative 3 and you have like a 1 over, that means to rewrite it as 2 cubed. Because if you're dividing by 2 3 times, I mean, that's the same thing as multiplying by 2 3 times. But you can also think of it this way. You could say 1 over a half cubed, and then this 3 distributes in. You could say 1 over 2 cubed, which is, because the 3 goes to the 1 and the 2, and you could think of it as being 1 over 1/8, and there's 8 eighths in a whole, so of course it's 2 cubed. So there's various ways of thinking about that, but in essence, remember that if you have a negative exponent in the bottom, it makes it move to the top, because you can think of this as being like 2 to the 0. 1 is always like a number, any number raised to the 0 power. So you take 2 to the 0 and think about what this does with the fraction. You have 2 to the 0 minus negative 3. That's like saying 2 to the positive 3. So because of that because of this idea, it's almost as if whenever you have something like this with the negative exponent below, you just kind of move it across the fraction symbol and it will become a positive. Likewise, if we have 2 to the negative 5, we could write this as 1 over 2 to the 5th, because this is like an enumerator position. you switch positions and it'll be change the sign of the exponent. So -5 on the top, but if you switch this to the bottom, it becomes 2 to the fifth. Keep in mind, this only works when we're dealing with just simply multiplications and divisions. I haven't said nothing about how this interacts with addition, really, up to this point. So really, these rules only work for strings of multiplications and divisions. We will be looking at how all this interacts with addition too. You have to be more careful because these rules don't really apply most of the time. If addition and subtraction are kind of like stumbling blocks on the top and bottom to these processes, unless you can actually undistribute something and then get a multiplication. Thanks for watching.